What's up, guys, and welcome to another installment of AP Chem Guide with Professor Kraus. In this installment, we're going to go over AP Chem free response question number 2 on the 2014 AP Chem exam. Without further ado, let's get down to it. Big Rod, the science guy. Big Rod.
Science rules.
Big Rod, the science guy.
Inertia is a property of matter. T minus 7 seconds.
Big Rod, the science guy. Produced by Bebop Productions. Alright, so in question 2, they start off by giving you an equation. The equation is for propanoic acid and its dissolution into water. So for the equation is CH3CH2COOH plus H2O is in equilibrium with CH3CH2COO minus plus H3O, or you could otherwise think of that as H+. Propanoic acid, CH3CH2COOH, is a carboxylic acid that reacts with water according to the equation that we just went over. At 25 degrees Celsius, the pH of that sample, which is 0.2 molar, is 2.79. So for part A, they want you to identify a Bronsted-Lowry conjugate acid-base pair in the reaction and clearly label which is the acid and which is the base. In part B, they want you to determine the Ka value for the propanoic acid at 25 degrees Celsius. In part C, they say, for each of the following statements, determine whether the statement is true or false, and in each case, explain the reasoning that supports your answer. So we're about to go and examine all of them. Alright, guys, so the first part of this problem is identify a Bronsted-Lowry conjugate acid-base pair in the reaction and clearly label which is the acid and which is the base. So for this, you're going to want to go by the Bronsted-Lowry definition. The Bronsted-Lowry definition of an acid is a proton donor, while for a base, it's a proton acceptor. And for this, you have a couple options, but I'm going to go with the kind of more obvious one, which is in the equation you see for A, CH3, CH2, COOH. Now that has a proton, and you can also see the other one that matches up with that is CH3, CH2, COO minus, and that does not have the proton. So what's going to happen is the CH3, CH2, COOH is going to be the proton donor, so that's going to be the acid, while the CH3, CH2, COOH will be accepting the proton, so that's going to be the base. For part B of the problem, we're going to have to work back from the pH to determine the Ka of the solution. So we know from the problem that the pH of the mixture, or solution, my bad, is 2.79. So we can find the hydrogen concentration from that. And what we do to find that is H3O plus or H plus yields or is 10 to the negative 2.79, which is equal to 1.6 times 10 to the negative 3. All right, and now from that, we know that the solution itself, we can make an ice table. So we know that the solution itself at the beginning was 0.20 molar. And these, the hydrogen and the conjugate base, were both 0. The change for this side of it would be minus x, while H plus would be plus x, and the conjugate base would also be plus x. All right, and then since we know what the concentration of the H plus is, we know that x equals 1.6 times 10 to negative 3, and it also equals 1.6 times 10 to the negative 3. Over on this side, it would be 0.20 minus 1.6 times 10 to the negative 3. All right, and now you know for the Ka formula, Ka equals the products over the reactants, so it would be 1.6 times 10 to the negative 3 times 1.6 times 10 to the negative 3 all over the reactant, which is 0.20 minus 1.6 times 10 to the negative 3, which gives you 1.3 times 10 to the negative 5th, which is the Ka. Alright, so now we're on to part C, and I'm going to repeat the question, which is, for each of the following statements, determine whether the statement is true or false, and in each case, explain the reasoning that supports your answer. So for part I, the statement is, the pH of a solution prepared by mixing 50 milliliter sample of 0.2 molar propanoic acid with a 50 milliliter 0.2 molar NaOH solution is 7. So let's examine that. So after examination, I found that the statement is false. Both the CH3, COOH, and the NaOH solutions are equimolar and of equal volume to each other, allowing them to be completely consumed as the solution has reached its equivalence point at the time of the mixture. The products formed from the reaction are consequently CH3, CH2, COO minus, and H2O, which then those products react to form a different reaction, and this is an equilibrium reaction with CH3, CH2, COOH, and OH minus being the products. Because of this, ultimately the solution has a basic pH because of the OH being formed, so it'll be above 7. Question CII is another one of the statements where you're trying to figure out whether it is true or false, and this statement is, if the pH of a hydrochloric acid solution is the same as the pH of a propanoic acid solution, then the molar sample of concentration of the hydrochloric acid solution must be less than the molar concentration of the propanoic acid solution. So let's try to examine this in the next part of the video. So for this statement, I figured out that it was true, and the logic behind this is that HCl is a strong acid which completely dissociates into H plus and Cl ions. So that means that the concentration of H plus is going to be the same as the HCl concentration, whereas whereas propanoic acid is a weak acid and therefore partially dissociates. And that means that the H plus concentration is going to be less than the concentration of the solution. And this means that the concentration of propanoic acid must be greater to counteract the partial dissociation in order to produce equal concentration of H plus and therefore equal pH within the solutions. Therefore, HCl concentration must be less than propanoic acid. Part D of the question is based on the scenario that they give you, which is a student is given the task of determining the concentration of a propanoic acid solution of unknown concentration at 1.73 or 0.173 molar NaOH solution is available to use as the titrant. The student uses a 25 milliliter volumetric pipette to deliver the propanoic acid solution to a clean, dry flask, and after adding an appropriate indicator to the flask, the student titrates the solution with the 0.173 molar NaOH reaching the endpoint after 20.52 milliliters of the base solution has been added. Now for D, they want you to calculate the molarity of the propanoic acid solution. And how I kind of went through this in my head was thinking first, when you set up the equation for the titration of the acid, you have the propanoic acid, which is CH3, CH2, COOH, plus the NaOH that will be added yields, because that will react and not form an equilibrium, H2O plus CH3CH2OO COO minus. So you can see from that equation that the monoprotic acid and everything else in there is in a 1-to-1 ratio. So because of that, I kind of wanted to make things easier on myself and use the handy M1 V1 equals M2 V2 equation. And when you plug into that and solve, you get M1 equals 0.173 molar times 20.52 milliliters over 25 milliliters of the propanoic acid, which equals 0.142 molar solution of the propanoic acid. So for part E, it states, the student is asked to redesign the experiment to determine the concentration of a butanoic acid solution instead of a propanoic acid solution. For butanoic acid, the value of pKa is 4.83. The student claims that a different indicator will be required to determine the equivalence point of the titration accurately. And based on your response to part B, do you agree with the student's claim and justify your answer? So from this, you're supposed to pick up on that you need to find the pKa of the indicator from the pKa, or from the Ka of the propanoic acid solution. So what you do is you take the pKa from the propanoic acid solution, and it is essentially the same thing as the pKa of the indicator. So pKa is equal to negative log of the Ka, and the negative log of the Ka is equal to negative log 1.3 times 10 to the negative fifth, which ends up being 4.89. Ultimately, it can be said that the student's claim, which was that a different indicator will be needed for the reaction, is false. And this is because to be a suitable indicator for the reaction, the pKa values of the indicator and the acid need to be pretty similar. And this is due to the fact that when the two values are similar, the moment the solution reaches equivalence point will coincide with the point where the one color producing substance is overtaken by the other in the indicator, and thus causing a color change. Since 4.89 is so close in value to 4.83, it can be said that the same indicator can be used for the titration of butanoic acid as the same one as propanoic acid. Okay, so now I'm going to ask you guys to do a practice problem based on some of the topics that we just went over in the question number 2 for the 2014 AP Chem exam. And the questions are, what is the molarity of a 50 milliliter solution of a strong monoprotic acid, HA, when titrated by 0.238 molar NaOH, where equivalence point is reached after 26.3 milliliters of titrant was used? That's question A. And part B is when a 20.0 milliliter solution with the same concentration of HA as in part A is titrated by 20.0 milliliters of 0.125 milliliter NaOH. Is there more of HA's conjugate base present in the solution, more of Na plus, or equal amounts of both? So you will have to use your answer from part A to find B. And in C, which is separate from both of them, is another student decides to perform an experiment with 0.19 molar acetic acid and its solution has a pH of 2.74. What is the pKa of the acetic acid? Now, go try those on your own and check back with the answers and the answer key that I will provide. It looks like that's all the time we have for today, folks. I think we were very productive, getting everything done, grinding, putting pen to paper. I'm very thankful to have you guys. It's such a great audience. It's really, really awesome to have you guys keep fueling me. You know, it's pushing me to do everything I do every day. This AP class, just amazing, top notch. Bunch of great kids, you know, and as a result, to thank you guys for watching this video, thank Miss Massey for a great year. I'm gonna put in some pictures of my dog at the end of this video. It's not like I'm trying to like stall for time anyway either, because like I really tried hard on this, and like I don't know. I just need to get to the 20-minute time slot, so here you go.